guys, let's continue our discussion on graphing circular functions. We are through with sine and cosine. Today we're going to discuss graphing tangent functions. And our learning competency, the same true with sine and cosine, and that is we are able to show the graph of the tangent functions showing its amplitude, period, and its phase shift. Okay, as we recall, from our standard form of our equation for the tangent is y equals a tangent b quantity x plus c plus d. Okay, where a is still referring to our amplitude. And later on we would show that on our graph how is this the significance of a in our graph of tangent. For b, okay, for us to solve for the period, we have here pi over b. So that's the value of your b. And of course, for c is called now your phase shift, which is either moving horizontally to the right or horizontally to the left. And of course, your D is called now your vertical shift. It's either upward or downward. Okay, let's have first our parent function. Okay, the original function, which is y equals tangent x. So how would we show that? Recall also that when we write tangent x, we have the value which is sine x over cosine x. And as we notice here, okay, once we get the identify the values of a and b, okay, our a here is 1, and that's why our amplitude also is the absolute value of 1. And for b is equals to 1, for us to be able to solve for the period, which our formula for the period is pi over b. So let's substitute the value of b, which is 1, or simply our period now is pi. Okay, meaning our tangent function is also a periodic function. Now for us to show that on our graph, okay, bear in mind that for sine and cosine, we have started it on our y-axis, particularly on the sine, the origin, and then of course your cosine, the graph starts on the maximum value. But for our tangent function, okay, the given period is to be divided into two equal parts first. So if it's pi, therefore divided by 2, both sides would have pi over 2. So on the positive one, we have pi over 2. On the negative side or the left side is negative pi over 2. Now, these endpoints now will serve as our what? Yes, that will serve now as our vertical asymptotes. So meaning the graph of our tangent should not pass over, okay, the given asymptotes. So we would draw a dotted line for us to determine that the graph of our tangent function later on would not pass over this negative pi over 2 and pi 2, which is of course this is one period. Okay, and then the next thing to consider upon considering our period is that we are going to identify 4 equal parts, okay, 4 points. So pi over 2 and negative pi over 2, obviously our center of that is simply 0. Okay, and then from 0 to pi over 2, what will be half of that? Yes, it's pi over 4. The same true on the other side, negative pi over 2 to 0. As we divide it into two equal parts is negative pi over 4. So there you have it, guys. We have the 4 equal points, which are negative pi 4, 0, pi over 4, and pi over 2. So these are our points. And this is again a significant when we graph. Okay, and afterwards we are now ready to identify also our um, as we plot the points. Okay, a while ago I have mentioned the value of our a, which is 1. Okay, and what is the significance of that? For the value of our a, meaning our amplitude 1 here and downwards negative 1, meaning that the second point and then of course that the third point would automatically considering this as our coordinate. So if we plot this one, automatically that's part of the graph of our um, tangent, which is pi over 4, 1, the same true. Okay, here negative pi over 4, negative 1. Of course, at the center is 0. The same true here. Okay, and of course, this will be our guide. These 3 points will be our guide as we draw our um, graph of the tangent, meaning it would not pass through over these two asymptotes. So once we draw a curved line, smooth curved line, okay, there you have it, guys. Okay, our graph of a periodic tangent function. So meaning, because this is said to be periodic, this would be copied, and of course it's to be extended on this left side and on this right side. Okay, so again, the graph of our y equals tangent of x, this is our graph. Okay, again, as we recall, before we have another example, of course, as we identify our period, from that period divided into two equal parts, okay, for us to draw the asymptotes, vertical asymptotes, and then from there identify another 2 points, okay, for us, of course, to use for the labeling and plotting for the given graph. Okay, and then of course the significance of the amplitude, it's that will serve as the coordinates for plotting the second point and then the third point of our graph. Okay, let's have another example. Oh, by the way, as you notice here, okay, so these are the given points as it's said to be periodic 1. Okay, so before we give an example, so take a look on this graph of y equals tangent of x. Okay, so there you have it, guys, the given coordinates. Okay, so this is said to be periodic 1. Okay, showing from sine and then the graph of the cosine. Okay, next one, our next example here is y equals 2 tangent 1/2 of x. Okay, so upon identifying the parts, okay, your 2 there is referring to our a, or that means our amplitude is the absolute value of 2. Okay, and again later on we would show that on our graph. um, that's not particularly the height of our given graph, but instead it would be significant in determining the coordinates of our um, graph later on in this tangent. Okay, and then what is 1/2? Your 1/2 there would be the value of b for us to be able to solve for our period. For our period is pi over b. Upon substituting the value of b, which is 1/2, so pi over 1/2. Okay, the reciprocal of our 1/2 in the denominator is 2 over 1, or simply 2. So therefore our period here is 2 pi. So again, the next step, after computing for the period of our given function, okay, divided into two equal parts. So 2 pi divided by 2. Okay, so meaning both sides starting from the origin is pi. Okay, so there you have it. So we need to draw a vertical asymptotes. Okay, and this would be copied later on from the left to the right. Okay, so the next is that after we have already the two values of our period from negative pi to pi, of course the distance of that is 2 pi. Okay, and of course considering from the origin, and then of course from origin to pi, half of that is said to be pi over 2, and half of this negative side also is said to be negative pi over 2. Okay, and then of course as we consider our amplitude, which is 2, so meaning 2 from pi over 2 to 2, this would be a point to be considered. Okay, then of course another one at the center, okay, from the origin, and then of course this one, negative pi over 2, okay, negative 2 here. Okay, so take a look on our graph again. We're going to connect these 3 points for us to be able to have our graph on tangent. Okay, take note again, if this is said to be vertical asymptotes, it would not pass over the given asymptotes. So there you have it, guys. Okay, so the graph of our um, function y equals 2 tangent 1/2 of x. Okay, so again the value of 2 as the amplitude is being referred to in our identifying the coordinates, okay, of our plotted points. Okay, let's compare. Okay, let's compare from the origin or your parent function, which is y equals tan x. And then of course from what we have solved a while ago, y equals 2 tangent 1 half x. And then of course 2 y equals 2 tangent 1 half quantity x plus 3. This time we have the horizontal or phase shift. Okay, and then of course y equals 2 tangent 1 half quantity x plus 3 minus 1. This minus 1 referred to now is our, yes, it's our vertical shift. Okay, let's try to show the graph of our uh, given comparison, okay, through the use of this app. Okay, so there you have it. Let's first show the graph of our original function, which is um, y equals tangent of x. So there you have it, guys. As it is said to be periodic, so there are lots of periods here in showing the graph of the parent function. Now, once we have entered also um, 2 tangent, y equals 2 tangent 1 half of x. Okay, so you would notice this time the significance of 2. Of course, comparing with our parent, which is said to be um, have a point from 1. This time, the value of 2 here, okay, is said to be this one. Okay, and then what's the significance of 1 half? So that means that 1 half there is said to be um, becoming, it would stretch. Okay, the same true once we have the value of our phase shift, which is positive 3. Once we enter this one, comparing, you would observe that it would move 3 units instead from working from the y-axis. This time it moved 3 units, okay, to the left. Okay, so there you have it, guys, from this orange colored graph. And what if this time we have entered this y equals 2 tangent 1 half quantity x plus 3 minus 1. This minus 1 is being referred to as our vertical shift. So take a look once we entered. Okay, there you have it, guys, that our graph, which is in colored blue, okay, it shifted from comparing from our 2 tangent 1 half x, which is this color blue, this purple. Okay, take a look, it what translated 1 unit upward. Okay, so there you have it, guys, this one. So that's the significance, okay, from comparing the period, from comparing our amplitudes, and of course the phase shift. Okay, so again, take a look of this and recall from our discussion also the same true in um, from the previous one, which is our sine and cosine also. So as we have our um, generalize, or let's say sum up our graphing of tangent functions, bear in mind, guys, of course, the first one is the amplitude. The amplitude now is being referred to the from the amplitude is needed for us to determine the coordinates, two coordinates from the second coordinate, and then of course the third coordinates. Okay, and then of course for the period, pi over b, if we compare with the sine and cosine, and this time of course divided into two equal parts. Okay, and of course the phase shift, it's either horizontally, okay, to the left, horizontally to the right, and of course applying your vertical shift, okay, it's either upward or downward. And of course our steps in graphing tangent function, you always remember, of course, identify the value of our a, b, c, and d, okay, with our formula for the period, and then afterwards, okay, divided into two equal parts considering the other coordinates or endpoints, okay, divided into two, and then of course considering our amplitude. Afterwards, we are now ready to connect a curve, okay, after plotting at 1 up. And bear in mind also that our graph for tangent is we have the asymptotes that it would not pass over with that, and we need to, if we would want to extend it, it's just a matter of copying the pattern to the right and copying the pattern to the left. Okay, so hoping guys you have learned something today once again upon graphing our third circular function, which is on um, tangent function. So again, see you again guys in our next lesson, which is on um, the remaining trigo functions. Okay, bye guys.